Hi, guys. Thanks for joining. This is Essence of Science. Today we're talking about gene mutation. I'm Amanda Armagost.
I'm Dr. Abbasi for Essence.
I'm Dr. Austin Beck.
Okay.
So,
What are you talking about?
gene mutation
And
the CRISPR.
Okay.
But we're talking about gene mutation, focusing on the CRISPR, but I'm talking about more the ethics of gene mutation.
Well, I would say let's talk about a little about the gene mutation. Without mutation, you and I, we would not exist, right?
Okay, that's not what I mean. I mean human, like science gene like in a lab,
So,
they're mutating.
like genetically modifying, intentionally
Okay.
genetically modifying. Just
Yeah.
in general as a concept, not so much evolutionary changes in genes, which happens at a constant rate that we all know of, but actually either trying to accelerate that through one way or another, or going on the far end and using CRISPR to actually make certain changes that what you want to happen in an organism.
So lots of people have heard CRISPR. Okay. What is CRISPR?
CRISPR is I don't think there's one word to describe it. It is incredibly fantastic, incredibly scary, and maybe incredible. Maybe that's just a good word for it to begin with. Yeah. A specific, excuse me. So it's a specific type of tool that would actually let us go in almost surgically and change a gene or a section, just a very, very small section of the gene. And then we can either add things into that, or we can actually take things out of that as well.
The way I read it is that it can cut a gene like scissors. That was hard for me to like visualize.
As very, very specific spots, because we've been able to like blast genes apart, right? But it's never been with finesse or precision.
But how did we find out about this tool?
I know that there's a guy who is in huge trouble.
No, a woman. Actually, two women.
Oh, I'm thinking of someone else, but tell me about the woman.
You want to go?
Go ahead. Yeah.
So, if you take a spoon of water in the sea, you have millions of viruses, and you have billions of viruses and millions of bacteria. 70% of the bacteria on the planet are dead because viruses kills them. And that has been happening over billions of years. So this bacteria, they are in constant fight with viruses. So over many billions of years, they have developed a method that if a virus comes and they survive it, they actually cut a piece of that virus, they integrate that in their own genes, and then they know if they see something like that, they have a mechanism of fighting it. So this is an evolutionary arm race between bacteria and viruses, that if a piece of virus that has caused harm to a bacteria has a mechanism of cutting that virus in pieces, integrating part of that virus genome in their own genome as a memory. This is what you should fight. And that's CRISPR. This is a toolkit, series of enzymes that, number one, they have a memory of here. This is the code that says what comes after this is something you should look for. Then they create something that next to that can attach to that get that part then get attached to protein. That protein then goes and activate a series of other protein that when they see that, they go and cut it exactly there. And
Cut it out.
Yeah, just so, but to do that, number one, you have to have a code that says, here it is, look for this code, number one. Number two, create something, the complementary DNA or RNA that would attach to this code. And once you attach to this code, cut it exactly when this code ends. And by having virus genome in their own genome and creating multiple things, these molecules, they go to the virus and they cut it in pieces. But that's not the important part. The important part is it should a mechanism exist to put that code in the bacteria's genome to start with. Because if you don't put that in the bacteria's genome, how do you know you should be fighting that? How would you pass this knowledge to your future generation? So those bacteria, for all future generation, they just will just keep going. And if that virus comes, that virus is out of luck because they have the mechanism of knowing that virus is bad for them and sending it multiple molecules that attach to that part of the bacteria, the virus of the genome, and it literally cut it in pieces and deactivate the virus. Now, that part that it recognizes it is not a good gene for them, and it cuts it and integrate in its own place. These are sequences that says, okay, take this piece, cut the chromosome in that location, and then add that gene here, and then come two other molecules and complete the chain. That's what the CRISPR is. Being ability to say to your, literally to your individual cells, build this sequence in specific location in your genome. And that literally it's a continuous thing. Like, you fix one cell, that cell can come literally multiplicate, and then all the next generation cells will have that genes integrated in them. And that enables you now like solve lots of genetic problems where we have a point mutation that something doesn't work. We can cut the bad piece out, put the good piece in, because we know what that good piece is. Like, for many of this genetic mutation, the problem is a point mutation that the sequence has changed and so on. If you integrate it back, you practically have solved genetic problem. That is, when I started my med school, this was science fiction. You could not imagine any time in our lifetime to be able to edit human genome in a live person like this, that literally edit human genome like that. Now, one of the problems here is that for something like thalassemia or sickle cell anemia and so on, or some form of diabetes and so on that are genetic, that you know what it is and you just put the right thing in and that really helps them. But I think the problem will become that, see, things that are very multifactorial and more complex like that, like I want to change my eye color to blue or my children's eye color to blue. There any kind of change that is so blind, it will start a cascade of things. We don't really know what the consequences of those chain reactions are.
Yeah, and there's social consequences too, like once people start having designer babies.
Well, I think that is very still science fiction to think that you can have a designer baby. Now, certainly, if you have a genetic disease, I think it's a legit that there's a 1 point mutation in one area and you want to have children. I think it's still reasonable to say, I'm going to fix that one little thing so my children don't have to die when they're 4 years old.
Yeah, I think if it's a matter of a genetic disease that's going to get passed down to your children, yeah, that's totally ethical to change that. But if it's like, I want my child to have blue eyes and blonde curly hair.
What do they say? 6'5", in finance, 6'5",
yeah,
blue eyes.
Yeah.
In finance, have you heard that thing from? No.
You're not allowed to
Oh
talk
my
then.
God.
Oh, I am. I just apparently have not gotten.
Okay.
Yeah.
So it
You
is
don't spend hours.
it is a viral, has gone crazy viral. This is this young girl, and it says,
Yes. No idea.
It says, I want a man in finance.
I'm looking for
a man in finance. 6'5",
blue eyes,
trust fund. And then people have made like lots of things about that. So, and the idea that you can genetically edit the 6'5", blue eyes, trust fund.
Yeah.
It is the
And when it's something like that, something so powerful, unfortunately, it can be used for good, but I hate to say it, but a lot of times the way I see things is that when something is so powerful, the people that have the more financial power can get a hold of it and end up using it for the wrong reasons.
But that's happening right now anyways,
Yeah.
if you have a financial thing, you're 70 years old and you can make your face
Yeah.
look like you're 40. Sometimes it goes wrong.
Sure.
Or that guy who had that I think he's like a Rockefeller or something. He's had 5 heart transplants.
I don't believe that in the United States is possible, that because of your financial situation. Maybe he went some other countries, because in the United States you cannot have put yourself ahead of somebody else just because you have more money. At least not officially.
Yeah,
At least not
officially,
legally.
but
You are familiar with the laws, right?
Yes,
With the transplantation laws and so on.
Yeah, and there are some things that you can do to try and get ahead on the transplant list. One of them being like you can list yourself in a couple different networks or areas. But yes, as far as I understand it, money is not one of them.
No, money is not one of them. And as well, donating the whole money to a hospital is not. I'm sure somebody probably will try that and so on. But I'm very optimistic that in the United States, the medical community is mature enough.
I'm not at all, not even 1% optimistic about that.
Yeah, well, I'm living it. I'm just can't imagine the consequences of taking somebody off the list, putting somebody else. So. But in some countries you can actually buy your transplant.
That wouldn't surprise me.
No, as a matter of fact, in Iran, there's a method that you can sell your kidneys.
Really?
And United Nations has looked into that. Actually, that Iran, they have no problem with kidney transplant.
Okay, so if you're going to sell your kidneys, how much would that get you in Iran?
Well, I don't know what the actual price is there, but see, if you sell your kidneys in a fair market value, and it seems that then there is enough people who are willing to do that. That number one, you get good kidneys, not like cadaveric kidneys.
Sure.
Number two is that it's all become a legal thing. Okay, and then there's protection on both sides and so on. And actually, United Nations has been looking into that, to giving that model actually has worked very well. Now,
see that.
and we have a lot of problem here because we try to be right, we try so bad to be right that people end up suffering.
Sure. Right, and the people end up suffering for a lot of different things. Matt, you mentioned the regulations earlier, and then taking it back to CRISPR, it's the regulatory standpoint that does make it a little bit difficult right now.
Oh yeah.
So one of Yuval Noah Harari's arguments with any type of these new technologies is that at first they'll be used for medical necessity. Like you talked about thalassemia or sickle cell anemia, or any host of these other genetic issues or genetic diseases that can be easily corrected.
Point mutation.
Yes.
That's
easy, fixed, done. But it doesn't stop there. The research doesn't stop there. And so you continue to tackle these more complex factors. And then eventually, sure, technology becomes better. And you brought up the cascade of, I'll call them unintended outcomes as you begin to handle those better. But it could get to the point where you can have these designer babies, as Matt was talking about, or you can have this superior human, if you will, this faster, stronger, smarter type of a person.
There is a movie called Gattaca.
Yeah, I was going to bring that one up.
Talk about what's the premise of that movie.
Gattaca is a really interesting movie. It's an old one. I think it's like in
very
the
old
early
one.
90s.
Yeah.
I think it was in the early 90s. And if I understood correctly, there was a law enacted in the United States because of that movie. I could be wrong.
Yeah, it was very, very, very determinant.
I haven't seen this movie.
So
you should see that.
It's an intriguing movie. But the whole point of this movie was that society at some point in the future had gotten to the point where it wasn't just that there were designer people. That was the expected. It's like if you were a good person, then and you were going to start a family, you would actually go to
expected, yeah.
You'd go to the doctor and you'd say, okay, this is what I want for my child, and everyone was virtually one of these elevated persons that's stronger, faster, smarter, and you would actually go out and get your genes sequenced, and you'd get a number rating. It's like, okay, and this number rating was how good your genes were.
And then you couldn't get a good job or something if you weren't a superior person. Now, like, half of your chromosome come from your mother, half of them come from your father. And some of the chromosome of your mother are coming from your grandmother and grandfather and vice versa. But it's a chromosome that you get. You don't get individual genes. You don't have that choice. But maybe some genes are better on your mother's side on this chromosome. On the same chromosome on the father's side, maybe another gene is better. But you don't have that choice to have the better on the same chromosome. And well, you don't have any choice. You get the chromosome just randomly assigned to you, and the numbers are astronomical. But the premise of this movie, Gattaca, is Gattaca, Gattaca. These are the nucleotome.
These are the letters, the nucleotides under DNA. Yeah.
So that they say, no, it is your child. It's just the best of you, because they combine and they see all your genome, and they just put together the best of you together. And these people are smarter, are faster, and so on. And they can, and then people who are naturally born, they're inferior. And then the main character of the movie is a normal person who want to be an astronaut, but he has no choice. So I'm not going to tell too much about that, but it shows the will, that the will triumphs over it, what it takes. If you are, as a matter of fact, I think that the social experiment movie that says what it takes if you are not privileged, even yet, yes, in the United States, what it takes to get where you need to go. Because if you are privileged, now that is a genetic privilege, but financial privilege is the same. Okay? If you are privileged, you can go to places. If you are not privileged, you cannot get to places. And what it takes for somebody who is not privileged to get to their goals, that is, I think, the premise of the movie. In that movie, it's about your genetic situation, but I think we live Gattaca every day. You come from a poor family who cannot afford to go to a good school, and every day is a shooting around your living place. You get shot in your knee, and then you cannot be an athlete because you have a bad knee. You got shot in your knee. So, but yes, we started doing a lot of laws about the genetic, modification and so on in the United States in the 90s, because these technologies, they started, coming up now. But CRISPR is very new. CRISPR is what, 7-8 years old technology?
Sounds about right.
Yeah.
Very incredibly new.
Now, when I was in med school, the hottest thing was PCR, polymerase chain reaction, where you could literally imagine, I get a swab of this table here. I can isolate the DNA of all our employees and everybody ever who have been here from that swab from this table. Because I can say, I want that part of that genetic material here and just replicate it. Go from 1 to 2, from 2 to 4, from 4 to 8, and so on and so forth. After multiple paths, you can astronomically increase the number of the genetic material there, and then you can, at certain point, then you can go and analyze it. You need certain number of that, but you can polymerase chain reaction, meaning that you just polymerizing more of the same copy. That was the hottest thing in 1990s. And that is actually where all these like Western blot, Eastern blot, and so on started. How we started, being able to break the chromosome, put it back together, get from understood how you can get from DNA to RNA and reverse transcriptase from RNA to DNA. But even then, all our tools, that was not imaginable that we can truly point edit our genetic material. And I should say, how powerful this technology is. So I understand the fear of people, what all the things you can do with that. If you understand enough, and the good or bad part, whatever you want to take that, these are not hard thing to do.
Yeah.
We could build a lab here, right here. We have the resources. We could order those machines and the samples and things and so on. We could do that right here.
Yeah, I think that's kind of like the ease of it is maybe one of the concerns too, because then imagine how easy it is for it to get onto the black market.
Now, I think that the intellectual part of it is that what are the consequences of what you do? That, except the point mutations, that understanding, what does it really, okay, you change the eye color, but what else has changed because of that? Yeah. That is, I think that's a black hole. I don't believe we understand that yet. So we should be fearful of that, and we should regulate that to a certain point. But I'm like anything else, I'm always afraid that, we are so afraid of it that a woman or a man, a husband and wife, are in the front of the thing. We don't want to have a child that we know is going to die with 4 years, but the law doesn't allow us to fix that problem. This is the downside of that. That where is the sweet spot? I don't know.
What are the current regulations of CRISPR?
I don't really know what our current regulations are. I think we are coming to grasp with it. I don't believe there are any laws, effective laws yet, because this is, the U.S. Congress doesn't work.
They have a lot of vacation days.
Yeah.
But I think that they're using it on insects and stuff. I heard that the fish at the pet store that glow in the dark, they were mutated through something like this. And then they made a glow in the dark cat before. I remember learning about that in school, and I was really bothered by it because I'm a cat person. I'm like, why would you do that? And then they're looking into mosquitoes, I heard.
Do you know what movie I see coming up? Blade Runner. We are getting there.
Blade Runner is coming up.
No. Blade Runner is a movie.
Yeah.
But about we create a race of human. Yeah. They're very strong, but they're enslaved to us.
I was wondering if it would be the other way, if they would become really strong and then we would become enslaved to them.
No, but that in that movie is we build them to serve us. So we have built certain things in their genome that if we don't give it to them, they just die.
Well, I heard that they're working with mosquitoes and they're trying to find a way to make the mosquitoes not interested in humans because mosquitoes are beneficial for the environment.
Right.
So
fish eat them.
Fish, birds, yeah. So many things eat them. And they're really good pollinators.
Mosquitoes?
Really?
Yeah, mosquitoes, Cassandra just told me, they're 2 skills. What?
I mean, if they're making mosquitoes, whatever they do to mosquitoes, they're not interested in me, is okay with me.
No, you will still, they're still going to love you.
No, see, if we go anywhere with almost anybody, like 100 people around,
everyone's
and there
safe.
300,000 mosquitoes are there, everybody's safe. And they come to me and they prove to me they can get me. Like I'm sitting on a chair, through the thick fabric of the chair, through the double seam of my gene, they sting me exactly where they're literally dead, like the double thing of the triple fifth things of my gene pockets are. So just to prove to me that they can get to me anywhere they want.
Got it out for you.
To get anywhere they want, or like if I have shoes, between my toe web and so on.
Stick an 8-gauge trocar right between all those 7 or 8 different barriers just to get to you.
Well, I think mosquitoes are attracted to a specific type of blood, so it's probably your sign that you should donate more blood.
I am donating more blood. I'm donating more blood to mosquitoes. No, but it's the true fact that for some reason these mosquitoes they're attracted more to some people or another. Some people just react more to it. They bite everybody equally, but then there's some people react more to that. What do you think?
Listen, also diet plays a role in being tasty to mosquitoes.
Is that
Really?
right?
What have you heard?
Shoot, I don't know. I'd have to go back and look it up. Maybe onions or garlic or something. If you eat a lot more, then they'll eat you less.
That's why they like you.
Oh, they eat you less.
Oh,
They eat
No,
less. You eat, maybe it's the opposite. You eat lots of garlic.
he eats
Oh, yeah.
lots
You
of
love your
onions.
garlic.
Lots of onion and garlic.
He eats onions like apples.
Eat more hamburgers.
Yeah. So coming back to CRISPR, it should be some regulation there. It's a very powerful tool.
Who do you think would own like the CRISPR technology? Do you think it would be owned by any type of
bacteria owns it?
No, I mean like a hospital system or like
I don't believe you can really own that the nature's
okay, but
path.
the CRISPR technology that they're using to do these
Just talking
things.
like the enzymes.
No,
Yeah.
I'm talking.
You can harvest them. Like
I'm talking about like, are they going to have any type of patent or anything on the actual
I'm sure
machine?
they will try. But
because I can see that being another huge issue. Like just an example, medical devices. Sometimes a device company makes a rule at a hospital that they can only allow that device pretty much. So I'm wondering if that would be some other issue where like one hospital system has this technique and now everyone can only go to that hospital. So, you know what I mean?
I do exactly what you mean. Let me tell you, first of all, this comes from nature. And nature has probably 1 million ways of doing CRISPR. There are billions of bacteria. Most of them have developed this technology or this method to protect themselves. But I totally understand that eventually in the realm of biotechnology, they find out that one of these or few of that is easier way for us to practically use that. They will develop that and then move forward and forward like videotapes. When they came out, there were so many different kind of videotapes, but few they had some advantage to others. And then at the end of the day, just VHS, you don't really probably know.
I know that.
But it doesn't mean that was the only way to create, videotapes. But it is the one that really all the technology developed in that direction. So I can imagine with CRISPR will be the same, even though I'm sure there are millions of ways of producing same results. Few will will be more common, and then all the companies will standardize that in a way that you literally you have a standardized way of doing that, and I'm sure they will create patents for that. And why shouldn't they? If they spend money to,
If they have it, sure.
Yeah, if they spend money, effort, knowledge on creating that for the good of people, they should as well be the winners of that. So anybody else can go and develop their own videotape and so on. Nobody prevent them to go and have a different kind of format for their videotape or audio tape and so on. Yeah.
What about like the example of abortions?
Mm.
So an abortion you can do at home when it's very unsafe. Do you think
I'm not sure how? I mean, you might talking about pills.
No, I'm
just talking about like regulatory standpoint.
No, okay, so like an abortion, you can go to the hospital and get it.
Okay.
But if you live in a place that you aren't allowed to get it, there's very unsafe methods. Like back in the day when they were first doing the Roe v. Wade protests,
lots of people died.
Women would walk around. They were dying because they were using like unsafe methods of abortions. For instance, a coat hanger. So they would use like coat hangers as. You don't know that?
I know that, but this is like my reaction to maggots that he was talking about.
So
using a coat hanger.
I'm wondering if it's possible that someday, what if someone else, like an individual, like let's say just someone random off the street, makes a CRISPR technology in their garage, and they say, "Okay, come over and I can do this stuff, so then you can have a child in this way." Is that possible?
Let's put it this way. Yes, it is possible. I think it is possible that you can have a CRISPR technology that build a gene somewhere in your thing, and you can have a kit that can do that for you, that is attracted to your, like, let's say your sperms and so on. Now, let's put it this way: it is much harder to do it for women than for men, because women's eggs are determined when you are
one egg, right?
Huh?
One egg a month versus
no, but all
the
the eggs that
Well,
you
yeah,
produce,
we get them all when we're born,
when you're
right?
born.
Oh, I see. Yeah.
But when you're actually 4, 5, 6 months age in your belly of your mom,
Mhm.
all your eggs for entire your life are already there. They're just encapsulated, preserved, and then your body gives them one after another. That's difficult. They're more difficult to do that because then they are more protected. They're already there. But men sperms, they're just produced as you go. I think it's more reasonable to do that than go and just change the spermatozoa, so that change it. I think it will be possible to have, but I'm just not, I'm extremely positive as well that people have that level of knowledge.
Yeah.
They don't need to do that in the garage.
Well, but it's also one of the points, though, against regulating this type of technology is that if we don't do it, then, well, we know for sure that North Korea or
China is already doing
Russia, and all of these other countries are currently engaged in it and doing it. And the point is, if we're not also developing this technology, then we're going to get behind, and they're going to have quite a substantial edge over us on that. And that's it is one of the fears against the ethics of doing this, is particularly for, like you mentioned, sperm and the eggs, because then you're technically experimenting on people who have not actually given consent for you to do experiments on them. And so that runs afoul of all sorts of ethical issues. And so it can become a very, very thorny issue very quickly.
Yeah, I can see that. Now that you mentioned that, now I'm thinking, imagine if you have a partner and you didn't know that they had any of their genes changed. Would you have to consent then to having a child whose genes would be changed? Does that make sense?
Yeah, it absolutely makes sense that, you don't see that all comes back to that. You don't know all the genetic garbage I bring.
True.
Nobody knows all the genetic garbage we carry with ourselves, and probably all of us had plenty of that. Now, I think the difference is that you have knowledge. You actively go and change something in your body. Now, is the other person allowed to have a knowledge of that? Let me give you an example that is really true. And this is a fact, okay? If you go to Iran, you see all these beautiful women with fantastic nose. You have a child with them, the child has a potato. They don't have a nose, they have a potato. Okay? Why? Because the nose you saw in that girl, it wasn't her nose. It was 2 surgeries or 3 surgeries. But should they tell you that, well, my natural nose is a potato, the nose you see and you love?
But I think that's
should they tell you?
That's so different.
No, but how is it different? No,
because
I don't
you're
think it's
changing
different.
Their nose. You're not changing their genes. Like, okay, let me give you a better example. I wouldn't want to have a child with someone who had a drug addiction, because I don't want my child to have whatever stuff went through that person's body and whatever's changed now. I don't want my child to have these issues. So imagine if I'm having a child with someone who changed his genes and we don't know the future effects of it. And yes, he got rid of some genetic disease that he can pass down, but now he has something else wrong. So I think that I should be able to consent to having someone genetically, scientifically
I think you should ask that person.
Yeah,
have you had any genetic change in your body and so on?
Yeah.
But you see that there. I'm not saying one way or another is better than the other. But you don't need CRISPR for that. You get a child with a beautiful woman who have a potato nose.
But isn't the point of CRISPR like, now you're not going to pass on the potato nose?
Well,
if
that's even worse.
Surgery,
but if they would have a genetic thing that would have changed their nose, my child would have better nose than potato nose.
I don't think you see what I'm saying. You're like, do you see what I'm saying? Or I might be really confused.
No.
Or are you being difficult?
I'm being difficult.
Okay. Yeah, let's put it out there.
I'm being difficult. I think you should be allowed to ask your partner, have you had genetic mutation that you fixed? Have you done anything that would affect my future children's life? But as well, you should be as well ask them, how many nose job did you get to get to this? I think that's legit as well. I think it's a legitimate thing to say, because we know like lots of drug addiction, there's a genetic component to that, right? We know that. So I think it's a thing. I think it's a good conversation to have. Have you had any drug addiction? And you have to be honest. I think it should have consequence if you hide things that you know affect another person and you don't disclose them. And then they get in a situation they didn't sign up for. I get it, but it's a conversation between you and that person. I don't believe that laws and rules and regulations should be imposed.
No. The laws can't tell you what conversations you and your partner have to have.
Yeah, and then that's also when you're starting to get into saying like, okay, like part of it though is the discovery of romance and love in life, and stumbling through all these unknowns as they present themselves. And so, like, you know, for better or worse, for richer or poor, till death do you part. Like the two of you are saying, like, hey, whatever, no matter what happens next, we're in it together.
Right.
And there's only so much that you can do to, I don't want to say protect against the unknown, but that is also the next leap that you guys take together, is that you're plunging to the darkness together. And so, yes, you can still go through and ask all these other screening issues.
Yeah.
But it's almost like you're getting to a point where you're saying, like, I want to protect myself against every possible adverse outcome.
And you might as well just live in a bubble.
So there is actually, again, I can talk about my birth country, Iran. Before two people marry, they have to get a genetic test profile. And if in their genetic test profile is that the children have a high likelihood of, or certain likelihood of some genetic disease, they're advised against marrying. I'm not sure if the law says they cannot marry, but they have to get a genetic test before they marry. United States is not the case yet.
Who pays for it? Like
government.
The government? Okay.
Government
I like
pays for
that.
it.
I like that the government pays for it. I think
and that they have to get it. Then if you have to get it, it's not like, you know, you feel offended if your partner asks for it. If it's by law, you have to get it, you have to analyze it, you have to discuss it before you get a marriage license. Considering we are talking about the Islamic Republic of Iran, I'm actually, you know, that's surprising. You know, that's surprisingly I would say forthcoming and progressive to say, you know, you have to get into this with knowledge rather than, you know, just figure out later on.
Yeah. But I think overall, genetic mutations for the right reason have more benefits, obviously, than negatives that we know, right?
No.
The potential.
Really?
No.
The potential, but that opens up the potential for all the other string of
all
events.
the unknowns.
For every 10,000 mutation, one of them is possibly somewhat beneficial. For every 100,000 to a million genetic mutation, one is significantly beneficial to the organism.
You're talking single point mutations.
Yes, I'm talking about single point mutation.
Not whole gene.
Oh no, I'm just talking about I'm talking about the single point. And this genetic mutation, they happen at certain interval. As a matter of fact, we have the genetic time clock. You can compare my genome to your genome to find out how many generations you and I ago. I mean, obviously we all came from one or two individuals, common ancestors, right? But with those markers, how many mutations there are in those locations, we can literally calculate how many generations you and I have been having the same ancestor versus, like, you know, maybe you and I had an ancestor 10,000 years ago, and then you and I, we had 20,000 years ago, something like that. Whatever it is, but you can calculate that. with that genetic, these mutations are they happen in certain way in certain intervals and so on. And those point mutation, again, vast majority of them are detrimental. No, a vast majority of them are neither good nor bad, but then there are a lot more bad than good. But the idea here is only the good ones stick around.
Yeah.
And then that is the beauty of the whole thing, that without those mutation, same thing that causes cancer, it would be no human. It would be still one cell organism.
Sure.
In the Z, and like looking around for sun.
Sure. But as you're saying earlier, though, it also opens up the bag of, okay, we might get like some sort of a beneficial gain of function type of mutation that also somehow causes a life expectancy of maybe like 15 or 20 years. But we wouldn't know that for about 15 or 20 years.
Yeah.
And so,
but the thing is about the nature is that once you have overcome your reproduction phase, nature doesn't care about you.
It doesn't care at all about you.
No. Yeah. Once you have the children, like Huntington, okay, you have Huntington, you have children.
Die when you're 35 or 40 years old, and it doesn't matter. You've already passed on your genes.
Yeah, go die. You don't care anymore.
But then you pass on that gene where they're going to die at like 35, right?
Well, but it's been passed on is the point. That's the point nature cares about.
Yeah.
So
if you passed
it's met its goal.
So anybody who is really interested into that, go read the book. They called Selfish Gene by Richard Dawkins.
Yeah.
Okay.
Thank you guys for watching. That was a little bit about gene mutation. I'm Amanda Armagost.
I'm Dr. Abbasi for Essence.
I'm Dr. Austin Beck.
Thank
Have
you
a safe weekend.